Deep inside every one of our cells, there's this incredibly powerful mechanism that basically acts like a master switch for inflammation. It's called JAK1. And figuring out how it works is unlocking treatments for a really surprising number of diseases. So today, we're going to dive in and break down exactly what makes this thing tick.
So let me just start with a question for you. What could possibly connect an itchy skin condition like eczema, a painful joint disease like rheumatoid arthritis, and a type of hair loss like alopecia? I mean, on the surface, they've got nothing to do with each other, right? But it turns out they all share this hidden, common link.
And here's our game plan for uncovering that link. First, we're going to hunt down that common inflammatory pathway. Then, we'll zero in on JAK1, that master switch itself. We'll see how targeting this one protein can treat so many different diseases. We'll get into the crucial balance between its power and its risks. And finally, we'll take a peek at what's next for this incredible class of medicines.
All right, let's kick things off. Time to go on the hunt for that single target, the one thing that ties all these seemingly random conditions together.
So at its core, the problem in a lot of these diseases is that the body's communication system has just gone completely haywire. I want you to imagine a smoke alarm that's just screaming 24/7, even when there's not a whiff of smoke in the air. That's pretty much what's happening here. The body's inflammatory signals are stuck in the on position, causing all this constant damaging inflammation.
Right, so how in the world do you turn that alarm off? Well, that brings us to the hero of our story, JAK1, the master switch. This is the protein that sits right at the center of this whole communication breakdown, the one relaying all those faulty messages.
So let's break down what this thing actually is. Janus kinase 1, or just JAK1 for short, is a protein inside our cells. The best way to think of it is like an old-school telephone operator's switchboard. It takes signals that arrive on the outside of the cell and literally connects them to the inside, specifically to the cell's command center, the nucleus, with one clear order: turn on inflammation.
This whole chain reaction is called the JAK-STAT pathway. And really, it's just a simple four-step chain of command. It all kicks off when a signal, a little messenger called a cytokine, docks on the outside of the cell. That flips the JAK1 switch to on, which creates a perfect docking site for another protein called STAT. The STAT protein docks, gets fired up, and then makes a beeline for the nucleus with a single order: switch on the genes that drive inflammation. It's an efficient system, but when it goes wrong, it's really destructive.
And look, this isn't just some abstract biology concept. We can see it in action. In conditions like vitiligo, where skin loses its color, and alopecia, we know one of the key culprits that kicks off this whole cascade. It's a specific signal called interferon gamma.
So what does this overactive signal actually do? Well, get this. In the skin of people with active vitiligo, this rogue signal cranks up the volume on other inflammatory messengers by 4 times. That is a huge, measurable spike caused by that faulty alarm.
And it's not just vitiligo. It's the exact same playbook in alopecia areata. A staggering 80%. Yeah, 80% of the immune cells that are attacking the hair follicles, they're being sent on that attack mission by the very same signal. It's the same pathway, just a different target. We found the common enemy.
So this all leads to a really powerful what-if moment. If one single switch is causing so many different problems, what happens if we can just, turn it down a notch? And this is where the story gets really, really exciting.
By creating drugs that specifically block or inhibit JAK1, suddenly we can tackle this incredible range of skin conditions. We're talking everything from atopic dermatitis, which is eczema, to the alopecia and vitiligo we just mentioned, plus intensely itchy conditions like prurigo nodularis, and so much more. It's a massive game changer for dermatology.
But wait, it gets even crazier. It doesn't stop at the skin, not even close. The exact same approach works for rheumatoid and psoriatic arthritis, inflammatory bowel diseases like ulcerative colitis and Crohn's, and even inflammation of the blood vessels. This is why JAK1 is so revolutionary. It's not about just one part of the body. It's a central control panel for inflammation everywhere.
Okay, but let's be real. Anything this powerful? Well, it's not going to come without some strings attached. Anytime you start tinkering with one of the body's master controls, you have to be incredibly careful. And that brings us to a really crucial part of the conversation: balancing the power with the risks.
So these drugs, called JAK inhibitors, come with a set of risks known as class effects, which just means they apply to the whole family of drugs. We're talking about a potential for cardiovascular events, blood clots, a risk of certain cancers that seems to depend on the dose, and a higher chance of serious infections. But here's the key. The takeaway isn't to be scared, it's to be smart. It's all about management, screening, and monitoring.
And that leads directly to this idea, which is so important. Risk-benefit assessment must be individualized. What that really means is this is the opposite of a one-size-fits-all pill. Doctors have to look at each person individually, their risk factors, how bad their disease is, what other options they have, and make a call. It is truly personalized medicine.
And another thing to keep in mind is that not all JAK inhibitors are the same. They're not interchangeable. This chart kind of shows you the selectivity of different drugs. See how some, like ubadasitinib, are pretty laser-focused on JAK1? Others, like baricitinib, hit both JAK1 and JAK2 pretty hard. Now, the thinking is that being more selective for JAK1 might give you a more targeted effect, while maybe, just maybe, dodging some side effects from hitting the others. But that's something scientists are still actively figuring out.
So, where does this all go from here? Let's take a look at the future of JAK inhibitors, because trust me, this story is far from over.
The pipeline is absolutely packed. We're expecting approvals for new conditions, like using upadacitinib for giant cell arteritis, and entirely new drugs are just around the corner. We're also going to see existing drugs get the green light for even more uses. The bottom line? This whole field is moving at lightning speed.
Okay, so after all that, what are the 3 big things to remember? Let's boil it all down. Number 1, JAK1 is a central hub, a master switch for a whole bunch of inflammatory diseases. Number 2, targeting that switch works, and it works incredibly well across different fields of medicine. And number 3, and this is the big one, the secret sauce to using these drugs successfully is that balancing act, weighing the amazing benefits against the known risks that we have to manage.
And that leaves us with one final and pretty profound question to think about. We're entering an era where we can target the absolute core engines of disease with incredible precision. And as we get better and better at it, the central challenge will be this. How are we going to balance this unprecedented power with the profound responsibility that has to go with it?